Hello guys. So today here I am to discuss something about the annual temperature range. So let us begin. So in continuation with the previous lecture where we had talked about the distribution of the temperature, let us talk today about the annual temperature range. So how do we define the annual temperature range? I will be writing it as ATR for short. So what is ATR? Whenever we talk about a range, so let us say the range of distance, range of height, range of weight, age range. For example, if in a class of 20 students, the student who is the youngest is, let us say, 18 years old, and the student who is the oldest is 25 years old. So we have a range between 18 to 25. Okay, that is what the range means. Similarly, the ATR will be the difference between the warmest and coldest monthly means. So for a location, if the warmest monthly mean of temperature is 25-degree and the coldest is 10-degree, so we have a range of 10 to 25. Okay, so that is what is called as the annual temperature range. Then the ATR, it varies from place to place. As we have already seen that there are several controls on the distribution of temperature and heat. So the ATR, it has variation in its value all along the globe. It is not same for the entire globe. Even in one location or one landmass, the ATR varies for the coastal regions than the inland regions. Okay, we'll have a look at this. Now, the interesting fact over here is the third point. Usually, the lowest monthly mean occurs a month or two after the winter solstice, while the highest monthly mean occurs a month or two after the summer solstice. So, when we are talking about the northern hemisphere, so you have these two diagrams over here, the summer solstice, winter solstice. So, let us talk about the northern hemisphere. So, what does it say? That the lowest temperature, the lowest temperature is not at winter solstice. Similarly, the highest temperature is not at the summer solstice. It is after these periods have passed. So, for example, 21st June is the summer solstice and 21st December is the winter solstice. If you take the mean average temperature or average temperature on that particular day, you will see that it will show some value. But in the month of June, the temperature will be higher than what is during the summer solstice. Similarly, the temperature during January will be lower than during the winter solstice. कायदे से क्या होना चाहिए था कि समर solstice में when we have the highest amount of insulation coming in, or a winter solstice में the lowest amount of insulation coming in, the temperature should have been highest and lowest respectively. लेकिन ऐसा होता नहीं है. ऐसा क्या क्यों नहीं ऐसा होता है? अभी हम सभी लोग जानते हैं that during the summer solstice, the tropic of cancer tropic of Cancer, it has the most direct sun rays. Most direct sun rays. Okay. Plus, the insulation is also the highest. Insulation is highest. But still, the temperature is not the highest. Why does this happen? This happens because the water bodies, water bodies, they have very high specific heat capacity. Specific heat capacity is, as you all know, that specific heat is the amount of energy required to raise the temperature of a unit mass by 1 degree Celsius. So, as compared to land, the water bodies have very high specific heat capacity. So, insulation is high, when the insulation is highest, the land masses will warm up very quickly because they have lower specific heat. But the water bodies, they are still warming up. They have not yet warmed maximum. वो धीरे धीरे अभी गर्म हो रही है. Now, as the solar position moves from solstice during June to July, यानी अब solstice से maximum हो गया. Now from June to July the amount of solar insolation will be lesser, but from the time of June to July the water bodies they gain up their maximum temperature. अब हुआ क्या? The land is cooled as compared to water bodies during July. लेकिन अभी भी जो वाटर बॉडीज हैं उन्होंने जितना हीट गेन किया है उसका टेम्परेचर अभी भी ज्यादा है. तो उससे जो निकलने वाला रेडिएशन होगा वो लैंड के कंपैरिजन में ज्यादा होगा. यानी due to the high specific heat capacity, water warms slowly and cools slowly, while land has lower specific heat capacity, it warms quickly and cools quickly. So during the month of July, when the land is relatively cooler than the water bodies, it will radiate less heat, but the amount of heat being radiated by the water body, it adds up to the terrestrial radiation. As a result, the temperatures they become very high. This is what is called as seasonal lag. So here you can see that in this plot the blue line it gives us the solar insolation while the red line is the temperature. So if you see over here carefully, at this point there is the maximum insolation, but the maximum temperature is not here, rather it is here. So this difference in time is called as seasonal lag. So when do we get the maximum insolation? In the month of June. But when do we get the maximum temperature? In the month of July. Similarly, during the winter solstice in the month of December, we get the lowest insolation, but the temperature is not lowest during the month of December, rather, it is during the month of January. So, this seasonal lag is a very important fact which you should know, that due to the differential heating and cooling of water body and land, because of the different specific heat capacity, this seasonal lag it comes in. Okay, all right. Now what are the factors that control the annual range of temperature? The factors that control the annual range of temperature, the most important is latitude. So we all have seen in my previous lecture that how the latitudinal variation of heat distribution is there. But if we look at the angles made by the sunlight with the earth, which is also called as altitude of the sun, altitude of the sun, so it plays a very important role. So if you see here at the equator, during the two equinoxes, during the two equinoxes, the autumnal equinox and the vernal equinox, the solar light is directly falling on the equator. That is the vertical insolation is there, which makes it uniformly heated. So within the year, within 1 year, the equator is uniformly heated two times by the vertical solar rays at the equator. As a result, the variation is very less. So when the variation will be high and when it will be low, let us say for example, the minimum temperature and maximum temperature for a location, minimum temperature is 10 degrees Celsius and maximum temperature it is, let us say, 20 degrees Celsius. And for a place the minimum temperature is minus 3 degrees Celsius and maximum temperature is 20 degrees Celsius. So if we see over here, what is the difference? So for the location A and location B, for location A, the ATR will be 20 minus 10, it will be 10 degrees Celsius. While for location B, it will be 23 degrees Celsius. If you 20 minus 3 becomes 23. So which places will have maximum annual temperature range, which have very low minimum temperature and very high maximum temperature? So there's a huge difference. But where the minimum and maximum temperatures are not quite differentiated, it will have lower annual temperature range. So the equatorial region, this the equatorial or the tropical region, they have extremely low annual temperature range. So this you should know that the tropics So from 23 and a half means Tropic of Cancer to Tropic of Capricorn, tropics they have low annual temperature range. Why? Because the constant heating of these areas does not allow the temperature to fall much. बढ़ सकता है, but बहुत कम नहीं होता, इस वजह से उनका ATR बहुत कम होता है. Now, we all know that the poles they have day and night of 6 months each. 6 महीना दिन होता है, 6 महीना रात होता है. So, if we go by this logic, then the poles should have maximum annual temperature range. But what happens is that two factors they do not let this happen. पहला factor है that the altitude from the of the sun at the poles is very low. So वहां पर जितना insulation receive होता है, it is not enough for the temperature to rise much. And second thing, the maximum amount of insulation, the maximum amount of insulation which is received at the poles is used to melt the ground ice or ground snow. Therefore, the range of temperature does not go much over here. But at which latitude it is maximum? At the mid latitudes. Mid latitudes. So what do we call as mid latitudes? From the Tropic of Cancer to the Arctic Circle, and then Tropic of Capricorn to the Antarctic Circle. Yani 23 and a half to 66 and a half. This is the mid latitude in the northern hemisphere, and this over here is the mid latitude in the southern hemisphere. So mid latitudes they have highest annual temperature range because here the seasonal variation is very high. So we get one thing, that if we go from equator towards the poles, the temperature conditions, they decrease, the variation. Therefore, the ATR is normally greater as we go from equator towards the poles. Okay, the variation in the temperature. So what happens over here is that due to the variable angle of the solar insolation, the heating is differentiated than the equator. So as we go from equator towards the poles, the range of temperature increases. But as compared to the mid latitudes, poles have a lower annual temperature range. Is it clear? All right. The second factor that controls is the height above mean sea level. The other day, I had told you that whenever we measure the isotherm, or we have to draw the isotherm for an elevated surface, we bring it down to the mean sea level. Of course, the height above mean sea level is an important factor, but it does not always control the atmospheric temperature. So, what there are three things over here. The height above the mean sea level, it operates with we all know that the air density at the lower height is more than the higher height. So air at elevated surface is rare, plus the cloudiness plus the amount of precipitation, they combine together to lower down the average temperature of those heights. But as I had already mentioned, that this is not a very important factor. Okay, then these two factors are extremely important: prevailing winds and ocean currents. We can never study the impact of ocean currents by ignoring prevailing winds, and we similarly vice versa. So the prevailing winds and ocean currents, they have to be studied together. Now let us say, for example, if you can see here the northeast trades, the southeast trades, the trade winds. So where the trade winds, what is the direction of trade winds? They blow from east towards west. So this is east to west. Now the trade winds, they as I have given in some of my lectures, I had talked about the Coriolis effect and the wind circulation pattern. Sorry guys, there was a bit of disturbance. Okay, so we can see here that the movement of these trade winds from east to west. So what is the impact of these winds? These winds, they bring the water from east towards west in form of the equatorial currents, north equatorial and south equatorial currents. These currents are going at the equatorial region, so definitely they will be carrying warm water. So wherever they go, they will modify the climate. Then see these westerlies. Westerlies, start from they start from west and go towards east. So see, if this is the direction of motion of westerlies, you can see the direction of Gulf Stream. The Gulf Stream, then the Gulf Stream, then Kuroshio current, then this East Australian current, then Agulhas current. All these are warm currents. They carry warm waters. Okay. Then we have these polar easterlies over here. So all these are cold winds. So the polar easterlies over here, see, they impact these currents like the Greenland current. Of course, these westerlies, they are also important wind for the movement of this ACC, Antarctic Circumpolar Current, which is also known as west wind drift. So we can see here that the prevailing winds, they also are the reasons for the movement of ocean currents. And wherever these warm currents go, they modify the climate, they lower down the temperature range. Wherever these warm currents are not able to reach, or these winds, they carry the they move from the cooler regions and go to us warmer regions, they bring in a lot of cold air that also reduces the temperature, so we get a different annual temperature range. So these four factors, there are several other local factors, the slope of the area, the elevation, and then uh, a few more we have, like uh, the distance from the sea, the precipitation and cloudiness. All these are other factors, but according to me, these four are the most important factors. The latitudinal variation, not four actually, this is three, because the height from the mean sea level, it also impacts the rarity of the air and the cloudiness and precipitation. So, ignoring that, we can have these three important factors: latitude, ocean currents, and prevailing winds, which control the temperature distribution and therefore impact the annual temperature range on the earth. A few features of the annual temperature range: as I just told you, annual temperature range is lower in low latitudes and higher in higher latitudes. When I say higher latitude, means we are uh, as as compared to equator, tropic of Cancer or tropic of Capricorn are higher latitudes. As compared to 23.5 degree, 66.5 degrees is a higher latitude. So as we go from the equator towards the poles, the annual temperature range, it increases. So it is lower in low latitudes and higher in the higher latitudes because of the variation in the maximum and minimum temperatures. At same latitude, the annual temperature range is higher over continents and lower over the oceans. Why does this happen? Because over the land, the lands, they have less specific heat capacity and therefore they warm quickly and they cool down quickly. Plus, they attain very high temperatures during the warmest month and very low temperature over the coldest month. As a result, the range becomes high. But the oceans or the water bodies, they warm gradually, cool gradually. Therefore, the difference in temperature is not much. As a result, the annual temperature range is less. North Pacific has a higher annual range of temperature due to its distance from equator. So as it goes far from the equator, it gets higher temperature range. Now, North America and Asia have higher annual range in the interior of land masses. So any continent which is surrounded by water bodies will have a higher temperature range in the interior, while lower temperature range in the coastal regions. The same thing is written over here, that within the tropics, the continental interiors have larger annual ranges than adjacent oceans. Just now we saw that in the tropical latitudes, the annual temperature range is not very high because of uniform heating. So the continents located in the tropical latitudes, they have higher range than the oceans located in the tropical latitudes. Why does this happen? Because of the differential heating of land and sea due to their uh, specific heat capacity. Now, Eurasia is the landmass which has got very high annual temperature range because you see the extent, how vast it is. Due to its vastness, as we go from west to east, the annual temperature range increases because now slowly we are going far from the water bodies. So the maritime climate over there will be reduced. A fact which you should remember, the annual range of temperature is highest at Verkhoyansk, the coldest place on the earth in Siberia, which is 65 degree. The annual temperature range is 65 degrees Celsius. How? In January, it has minus 50 degree as the lowest temperature. In July, it has plus 15 degrees as the highest temperature. So 15 minus 50, it is 65 degrees Celsius is the annual range of temperature. Sometimes this range has reached up to 104 degrees Celsius. So you can imagine how low and how comparatively high it can go. So I hope you understand this features of annual temperature range, and annual temperature range is very, very significant because it has a large environmental impact. If the annual range of temperature is very high, it will have a different stress on the biological activities in that region. If it is low, there will not be much variation in the biological activity. So, for the survival of the biota, this annual temperature range is important. Also, in the polar regions or very high latitudes, for the life to survive, this temperature range is also important. So that those areas may have an equitable climate. It's not like that the poles are or the higher latitude regions, they are always under extremely low temperature conditions. Just because of this annual temperature range variation, the life may sustain over there. Okay, so I hope you will appreciate this and you will read more on this. We'll see in the next lecture. Thank you.